All right, here we are with the practice test. This is Unit 6 practice test. Same formulas as we've always been doing, so I'll try to hint you in and remind you of what to do as we go along, but it's pretty straightforward. All right, so let's go ahead and get started. What I am going to do is the key to success on these is setting up your calculator. So I'm going to be putting my x's, the individual numbers, into list 1, and the number of those, the frequencies, into list 2. So the probability of something in general, again, is the number of them, so the individual frequency, divided by the total number, aka the numbers of all the frequencies put together. And so that is, in essence, what this first problem is going to be, is finding these probabilities. So what it is we're going to be finding a probability for each one of those things individually. So my answer to this is going to be a list. So what I'm going to do is I'm going to take that list and I'm going to make that list 3 in my calculator. All right, so here is the formula that I'm following, and now I need to find the individuals for individual probabilities for 0 to 7. So I set up my calculator with my list 1 and list 2. So again, that's the individual numbers and then the number of those numbers. Just double check that I didn't make a accidental button push somewhere. Okay, it looks like we're good to go. So the first one is to find these probabilities. What you do is you take the individual numbers of the things, so the individual F, so 9, 72, 73, 60, 63, 70, 41, and 28, etc. And then I divide each one of those individually by the sum of the numbers. So the individual probabilities are those. So what I do is I take that list answer and store it as list 3. All right. And so that's what the first question is asking me for, is what are these individual probabilities? So if my x's are 0, 1, 2, 3, 4, 5, 6, and 7, let me get this writing out of the way here. I'm finding that the individual probabilities of these should now be whatever I put into list 3. Those are the P of x's. So what are these individual probabilities? And so if I look at my list 3, those should be the individual probabilities. 0, 3, 7, 5. Again, make sure you're looking at the bottom decimal, not the highlighted decimal. This is 0.3, 2625. These are nice numbers. Oh, there's one. 1708. Here's one that we have to round, 1167. 0583, 0333, and 0208. Okay, the rest of these problems are just using these probabilities to figure out whatever you need to figure out. So the first one is, what is the probability that x is between 2 and 5? So what is the probability that x is between 2 and 5, including 2 and 5? So that would be the probability of 2, 3, 4, and 5. So we know what those individual probabilities are. now all we have to do is just physically add them up. X1 is that it's less than 3, specifically less than 3, so that does not include 3. And less than 3 does not include 3. So these are the things that I have in my calculator. And next is, what is the expected value? So that question is asking for what is mu, which is the formula x px. So just make sure that you have all the pieces in your calculator. We have an x, and we also have a px. So all we have to do is just use those pieces as we're supposed to. So the sum of x px. And around that number. All right, what I'm going to do is I'm going to just take that answer and store it as the letter u. So again, updating what I have here, mu is now the letter u. So if I ever need it again, which I will right now, I have it at my disposal. This next formula is the standard deviation, which is the sum of x minus mu whole squared px. Okay, so we need an x, a mu, and a p. An x, a mu, and a px. So an x, a mu, and a px. We have all those things stored in our calculator, so we have everything that we need. This is going to be the sum. Double open, x minus mu whole squared px close. There it is, easy peasy. Backside, these are general probabilities of success. We don't know the actual numbers of success, but we have a likelihood of success happening. So that's R. So the formula is going to be the NCR formula that is going to be used. All right, so back here we have the health director, health club, et cetera, et cetera. So the probability of success is 23%. That implies failure is 77%. We have a total of N, so 10 people using the pool. We want to know that the specific number of successes is 4. The formula that I'm using for this is probability of a specific number of successes is NCR, P to the R, Q to the N minus R. I don't know about you, but I have to make sure I put that in its own parentheses. So that is how you find an individual probability from these problems, from a general likelihood of something happening. Smaller too, and I'll fit this all in here. Okay, so this first problem, we don't have to make any lists or anything. We can just answer the question that's being asked. They want to know what is the probability that 4 will use the pool. So that's NCR P to the R times Q to the N minus R. All right, same idea with these next one, but we have to know a bunch of different probabilities. So we need to know a bunch of different ones. So what we're going to do is we're going to create this R as being a list. So here we have the total number of mountain climbers being 11. That means the number of successes could be 0, 1, 2, all the way up to 11 successes. The probability of any individual success is 65%. That means failure is 35%. Again, the general formula of finding an individual probability is NCR, P to the R, Q to the N minus R. All right, so these are the individual probabilities. This is the setup. And so what I need to do is I'm going to take this R and I'm going to put it into a list. And then I'm going to do this formula, and wherever I see an R, I'm going to say, list 1 or something. And that will spit out individual probabilities for 0, 1, 2, 3, 4, 5, 6, et cetera, et cetera, et cetera. All right, so this is where I set up my individual R's. All right, and now I plug and chug into that equation, which is N, C, R, and again, R is now list 1, times P, so the P is 65% to the R, list 1, times Q, which is 35%, to the N minus R, again, R is list 1. So bam, these are the individual probabilities of 0, 1, 2, 3, 4, 5 number of successes from a general probability. So those are the individuals. So what I'm going to do is I am going to take that list answer and I'm going to store it as list 3. That's usually where I put my probabilities. So that's what I do there. Okay, so now all I have to do is answer these individual probabilities with the probabilities that I have written right here, similar to how I did on this front side. Okay, so here we go. The first one is the probability that all 11, so that's just the probability of 11, that's easy peasy. At least 9, so that means the probability is greater than or equal to 9, so that would be 9, 10, and 11. All right, no more than 3, so the probability that R is less than or equal to 3 would be the probability of 0, 1, 2, and 3. That is going to probably involve a lot of zeros. And then because this is an OR, the probability of that is 9, 10, and 11. So again, that is exactly the same thing as the answer to B. So I wouldn't expect that on the test, but whatever. It is what it is. All right. So all we got to do is find these probabilities, add up what we need to add up, and things like that. Okay, so the probability of 11. Again, I'm looking at list 1 for the 11. There it is. So this is E negative 3. That implies that there's going to be 2 zeros. And then an 8, 7, 5, which would be an 8, 8. Right there. All right, so going backwards, we have the probability of 9, which is 1395, plus the probability of 10, 0518. and the probability of 11, which again is the one that I just found. And just add those together. So 1395, 0518, and 0088. So 0.2001 of at least 3. So again, there's probably going to be some major zeros in this one, yeah. So the probability of 0 is 5 zeros, 9.6. So if the next numbers are 9.6, this would be 0.00001 right there. So that would be 4 zeros and a 1 when you rewrite that. Unique situation. Okay, the probability of 1 is 3 zeros and a 1, 9, so 3 zeros and a 2. Probability of 2 is 2 zeros and a 1, 8. And the probability of 3 is 0, 1, 0, 2. It's a little bit smaller so I can fit in my writing here. So the first one is 0.12341, 1232, 1218, 0102. All right, so this is where I officially lop off some of the numbers. This is 0122. And again, I did this just a little bit earlier. This is 2001. Have that in there. All right. The most overthought problem in the entire process is this one right here. Coach found that 12% of hockey games end in overtime. There's 50 hockey games being played. So that's 12% of those 50 games. 6 games. Easy peasy, don't everything down. All right, and then last but not least, we have the mu, which is going to be the sum of x px, and the sigma, which is the sum of x minus mu whole squared px. All right, so what do we need to get out of this? So this is what we're kind of considering. Here, n is 5 truck drivers. R could be 0, 1, all the way up to 5. This is like x. This is kind of like x. It's the same difference. Okay, so that is most likely going to be list 1. Okay. We have a probability of success being, in this case, 65%. That means failure is 35%. The probability of an individual success is NCR, P to the R, Q to the N minus R. This is pretty much saying this is P of X, which I'm ultimately going to be storing as list 3. Okay, the other storage is when I get this answer for mu, I'm going to save it as the letter U. Okay, so I'm working towards that first question, and I need to get the PX, or yeah, the PX, or AKA this P of R, to make that work. So I set this up in my calculator. Stuff in there. So my R is, or X in this case, is 0, 1, 2, 3, 4, and 5. And where I go from here is I set up this probability. So that's N, C, R times P to the R times q to the n minus r. Okay, those are my individual probabilities. As I said, I am going to take that list answer and store it as list 3. Okay, so list 3 is now my p of x's, but we're not done. So now I have the important ingredient, so I can go ahead and actually do this first question with what is mu, which is going to be the sum of xpx, the sum of aka list 1, list 3. Okay, that is my mu. What I'm going to do is I'm going to store that as the letter u, and then I'm going to get mu. So that's going to be the sum, open, open, x minus mu, closed, squared, px, closed. So the mu was 3.25, and the sigma came out to be 1.3, excuse me, as you were, 1.1375. That's it.